So, before we start taking notes, I'm a boy mom, right? So we didn't watch Cinderella at my house. We didn't. Well, I did make them watch Cinderella. This is my favorite movie, and I was just like, you know what? I don't care. But we didn't get to play with dolls, all these kind of things. We watched superhero movies. We watched those movies where people shoot each other all the time. And so this kind of, at the beginning, is really more for my boys, except for, you know, those girls in here that have older brothers. Like, I know Mason D's played Transformers with her brother. I'm 100% confident about that. So, see if any of this rings a bell.
Autobots place their pedal to destroy the evil forces of the Decepticons. The Transformers. Transformers. The Transformers.
Did you have Transformers? I know you did. You probably packed them up and took them over to your parents' house and y'all played Transformers. Am I right? Yes. Now, what does a Transformer do? What is? Okay. So give me something that's not in the name. What does a Transformer do? It changes, right? So we have this car, and it flips around, and maybe its hood becomes like its back, or like its wheels become its hands. And so you turn it, and you rotate it, and you flip it around, correct? And we go from a car, or a motorcycle, or an 18-wheeler to a robot. Now, who's watched the real Transformers movies, like the big time?
Michael Bay.
Yes. What's his name? Mark Wahlberg. What's her name? Fox.
Megan Fox.
Thank you, Megan Fox. Those kind of movies. Who has watched those?
Shoot.
Okay.
Yeah.
If you haven't, go watch Transformers this weekend. Okay? It's a good movie. There's lots of them to pick. Now, Garner, who is the leader of the Autobots?
Optimus Prime.
Optimus Prime. That's going to be important in a minute. See, like Mary Catherine back there, this is an all-girl family. She's never even heard of Optimus Prime. She has no clue what's going on, okay? So, Mr. Geometry was very into the Transformers. So, when he was doing this, he even used Prime as part of this. So, he's going to come up in a minute. So, in geometry, a transformation is an operation that maps an original figure called the pre-image onto a new figure called the image. It maps an original figure called the pre-image onto a new figure called the image. So we're going to have this pre-image and we're going to do something to it. We're going to rotate it. We're going to translate it. We're going to reflect it. We're going to do something to it. A transformation can change the size. I don't really like what these notes say. They say shape, and I don't like that, so I'm going to get rid of it. Or it can change the position. I don't like to say that it can change its shape, because if you start with a triangle, you're going to end with a triangle. If you start with a square, you're going to end with a square. Now, it can get bigger. It can get smaller. It can move all around the coordinate plane. It can flip over, but we're not going to be changing it from a square to a parallelogram. Okay? Now, give me an easy word. Like, you have a little brother, and you're trying to tell him what a reflection is. What word would you use?
Mirror.
A mirror. I'm looking for an F word. Flip. So a flip over a line called the line of reflection. Do you remember last year when you were doing parabolas and you had that axis of symmetry? It was the same on both sides. Kind of the same thing here. This is your line of reflection or line of symmetry. With a reflection, each point and its image are the same distance from the line of reflection. The same distance from the line of reflection. So, for example, in this little picture over here, this is your pre-image. The reason I know it's my pre-image is because A, B, and C are just normal letters. We're going to reflect over this line, and we're going to go to my image. And the reason I know that's my image is because this is like A apostrophe, right? But in geometry, we don't call it A apostrophe. You know what we call it? Who's the leader of the Autobots? Correct. So this is A prime, B prime, C prime. And we're going to get into more than one transformation. We're going to go from there to another one and there to another. So we're going to have like A double prime. But just one today. Now I want you to put a little star here, especially if you see a tutor or you're just talking to some math teacher in the hallway. Possible lines of reflection, there are more than the ones I'm about to list, but these are the ones we're doing today. The other ones we're going to get to are going to be later. You can reflect over any line you want to. You can reflect over any horizontal, vertical, diagonal line, but today these are the only ones we're going to do. So you can reflect over the x-axis or the y-axis. The x-axis or the y-axis. You can reflect over vertical or horizontal lines in the form x equals some number or y equals some number. Like x equals 2 or y equals -7. We can reflect over that. And you can also reflect over diagonal lines. You can reflect over any diagonal lines, but for today we're only going to do y equals x, bless you, and y equals -x. Thank you. I did remember. Okay, so let's start off with an easy one. So let's go to number 1. So number 1, we're going to take this triangle, ABC, and we're going to reflect it in the x-axis. Is my x-axis the one that's vertical or horizontal? Horizontal. So the first thing I want you to do is I want you to graph ABC, and I want you to plot the points and label it ABC. Miss Jackson has a pet peeve. She does not like when you have to graph and it goes off the graph. So if you're in my classroom and it goes off the graph, you've done something wrong.
You want us to draw the lines between the triangles?
Yes, please. Okay. Now, if you look at that sheet that I gave you that have all the rules, there is a rule for you to memorize if it reflects over the x-axis. But if you get on the test and you forget the rule, you don't have to memorize it. So what you're going to do, if you forget the rule, is you're going to count. So if you're at this point A, how many units are you from the x-axis?
2.
2. So we're going to go 2 more in the other direction. And that's going to be your A prime. How many units is C? 1. So we're going to go 1 more. Bless you. And how many units is B? 7. So we're going to go 7 the other way. Make sure you put your little primes on there when you reflect to your image. Now, when you look at this, what changed about your ordered pair? Did your X values change or did your Y values change? Your Y values, your X values stayed the same. And if you look at your reference sheet, it will tell you that when you reflect on the X axis, that you're changing your Y values. So this is going to be -4, -2, 4, -7, and 5, -1. Easy? Okay. I want you to start working number 2. Number 2 is a rectangle, but what else about number 2 is different? There is 4, and what else? We're reflecting in the y-axis. Okay, so instead of counting from the x, we're going to count from the y. Okay, so I want you to start graphing this rectangle. Now, when Lytle's on his test and it says rectangle QRPS or whatever, and he graphs it and it doesn't look like a rectangle, go back and check your ordered pairs. Sometimes you get cocky on this because you're like, oh, I can graph, I don't have a problem. And you give me some graph and it's supposed to be a rectangle and it looks like a trapezoid. Or you graph a rectangle and then your second image looks like a trapezoid. You've done something wrong, okay? All right, so we are now counting from the y-axis. So how far is Q from the y-axis? 2, so go 2 this way. How far is P? 1. R is 8. And S is 7. When would your original point and your second point be the same? If it was on the axis. So if we, or if it, you know, the origin always would be as well. So if it's on this axis and it reflected over, it's gonna, that would be stay. It's gonna be like a pivot point. Okay. Okay. Is there anybody in here who needs, like, do y'all feel like y'all can do this? Easy cheesy lemon squeeze. Okay. Oh, let's talk about this. What happens to my ordered pairs? What is changing? The x values. So you're just going to take this and change your x values. I believe if you had Miss Waits, she taught you the rule. She didn't say count, did she? Didn't she teach you the rule? Okay. But I want you to know that if you get on the test and you forget that, that's what you're going to do. All right, so the bottom 2 are the same thing. So turn it over and let's go to number 5. And number 5, we're going to reflect in the line x equals 4. What kind of line is x equals 4? A vertical line. So we have one extra step here. I want you to graph the line x equals 4. So if it's not an axis, you need to graph the line. All right, so let's graph triangle JKL. Is there a rule for every horizontal and vertical line to memorize? Like there would be for the axis? No, we're going to have to count. Okay? So if you're reflecting over x equals 4, then just go and count. So we're 1 here, so we're going to go 1 in the other direction. My lines are really hard to see. And then to get your ordered pairs, you're just going back to the origin and you're figuring out what these ordered pairs are. So somebody tell me what J prime is. J? 7, negative 1. What is K prime? 6, 3. And what is L prime? 5, negative 2. Do y'all understand where I'm getting? Like I'm just counting the ordered pairs? Because you're going from this line, not an axis. So we're not using the flipping and things like that. Okay? Yes? All right, so I want you to try number 7. Okay, number 7 is a parallelogram, and what are we reflecting it over? No, number 7. Y equals 2, which means it's what kind of line? Horizontal. All right, y'all start working on 7. So I'm going to graph up here while y'all are graphing just so it won't take me as long to go over it. So don't look up here if you want to do it on your own and check. And when you finish, I want you to check it with mine. Did we get that? Feel good about it? Okay, again, don't start with a parallelogram and end up with a triangle. Okay, go back up there and see, or don't start with a parallelogram and then have one that's way off the graph. You've done something wrong, okay? All right, the last type that we're going to do for right now are reflecting over y equals x and y equals negative x. Now, when I talk about the line y equals x, what is my y-intercept? 0, the origin. what is my slope? 1. So this is going to be a line with a slope of 1, and it's going to start at the origin. Okay? Now we have to memorize the rules for this. We can't count. I mean, we can, but we don't want to have to. We can count it, but let's don't, because that we would have to use the slope, perpendicular slope. So go to that sheet that I gave you, the rule sheet, and tell me what you're supposed to do when you reflect over the line y equals x. What do you do to your ordered pair? Flip it around. So instead of xy, it's going to be yx. So we're going to graph our original triangle, our pre-image, and then when we graph our image, we're just going to take those ordered pairs and we're going to reverse them. Now, if you're on your test and you go to reflect this, in what quadrant should this end up in? If it's here, we're going to flip it over here. So if you graph it and it's in the first quadrant, you've done something wrong because it's reflecting over here. This is a little off here because I think I can't see my lines on this one. Okay, so you got to learn the rule for this one. We're not going to count because you have to count diagonally, which means you have to talk about perpendicular slope. We're talking about distance.
Do we have to like put the label the points?
Yes. So on these types of problems, I'll grade it like each piece. So if you graph the first triangle correctly, that's some points. If you get the ordered pairs correct, that's some points. If you get the line, has to be there. If you get the second one. So it's not like if you miss one ordered pair, you miss the whole 8-point problem. Okay. All right, the last type of this is going to be y equals negative x. What's different about y equals negative x than y equals x? We're going to have a negative slope, okay? So I want you to work number 11. Look at your rule sheet and see what you're supposed to do to your ordered pairs. And while you do that, I'm going to give out the last sheet for today. Okay, what do you do to your ordered pairs for this? What do you change your x, y to? Not only do do you reverse them that you also change your sign? So you do negative y, negative x. So this is going to be like negative 3, 1, negative 6, 0, negative 5, negative 3, negative 2, negative 2. And this square should reflect down here into quadrants 2 and 3. You what?
I had number 12 instead of 11.
What, Carter? Did you do it right?
I think so. It was y equals negative x.
Okay, good. Okay, so let me talk a minute before we talk about translations, what I'm expecting from you on homework for this chapter. So we will never work every single possible one on the note sheet. So like as of right now, I think you have 6 that we haven't worked. We've worked one of every type, and then there's another one of every type. So you can go through and work these. Now, I have also posted, there are 4 types of transformations. Reflections, rotations, dilations, translations. I have posted 4 sheets, one for each one, of extra practice and the key. So you have a whole nother sheet on Google Classroom. I don't even know if it's like 12 or 15 problems with the key on Google Classroom. So if you need to work more practice than just these 6, and you have the key to work it, you can do that, okay? All right, so we're going to talk about translations before we leave today. Translations are easy. You don't have to learn any rules. You don't have to memorize anything. So for reflections, you're going to have to memorize. You've got to either count or you have to memorize the rules that I gave you for the diagonals, okay? Translations are not as hard as that. Translations are probably the easiest other than dilations. All right, so if a reflection is a flip, okay, it's a flip over a line, what is a translation doing?
Moving it. Sliding.
It's sliding it, it's shifting it. So you can put slide or shift, it doesn't matter to me. In Algebra 2, you say shift. Slide's kind of a baby word, but I don't care if you say that. But shift is what you say in Algebra 2. So let me give you the symbolic form, what it looks like in letters. So with a translation, they always have to give you a rule. They have to tell you what to do to it. So symbolic form is always going to be x, comma, y, and then you're going to put an arrow. And then it's going to be x plus h, y plus k. Now, using the really, really big brain that God gave you, is your h value going to move you left, right, or up, down? Left, right, because what is it changing? The x. So h is going to represent your horizontal shift. It's what's going to happen to your figure left and right. So if h is your horizontal shift, k is your vertical shift. Who remembers vertex form of a parabola? Remember h and k? And the h value moved you left and right, and your k value moved you up and down. So that's what's happening here. So if I look at number 1, before I even graph it, I can figure out what my numbers are going to be. Because I'm going to take this rule. See how the rule changes every time? It tells me what to do every single time. So what am I doing to this rectangle? Is it going left or right? It's going right 5. Is it going up or down? It's going up 7. If it's minus, see, that's going left 3. Okay? So here, what are you going to do to every x value? You're going to add 5. What are you going to do to every y value? You're going to add 7. So let's do that. That's going to give me negative 1, 6, 2, 8, 6, 2, and 3, 0. Whatever the rule tells you to do, that's what you do to your x and y values. Okay, so let's graph this. And you get tired of graphing and you say, Miss Jackson, do I really have to graph? Yes, you do. And don't get cocky about it because you do and then you mess it up and these are easy points. Now, before I graph this other one, I have my rectangle, so it's moving to the right 5 and up 7. So if you graph it and it doesn't do that, you've done something wrong. Okay, thumbs up or thumbs down? Thumbs up, we can do this. All right, so go to the back. I'm going to show you the last thing for today. And I want you to look at numbers 7 and 8. So on the first page, on numbers 1 through 6, you are just following the rule. You're graphing, you're doing what the rule tells you. But on 7 and 8, it's asking me to write the rule. Okay, it's giving me both of them. Now, how do I know where to start? Which one is my pre-image? The one without the apostrophes. So this is figure 1, this is figure 2. You're always going to the primes. Now, are D, E, and F going to shift the same way? Are they going to move over the same amount?
Yes.
Yes. So it doesn't matter which one you pick. I'll just pick F. Okay? Is F moving to the left or the right?
Right.
The right. So I want you to write X, comma, Y, arrow, and then are we going to add to X or subtract from X? Add. So we're going to add. How many units did we move over?
7.
7? Y'all agree with her? Okay, good. Are we moving up or down? Up. So we're going to do Y plus. Y plus what? So Cooper, what I mean by that is whether you picked F or whether you picked E or whether you picked D, you're going to go over 7 up 4. So it doesn't matter which one of these you pick. Okay? All right, I want you to write the rule for number 8. Okay, so you're going to write X, comma, Y, put your arrow. All right, are we moving left or right? Left, aren't we? So are we going to subtract or add? Subtract, because we have to start with the ones that don't have the apostrophe. So I'm just going to do P. All right, so we're moving how many? 4. So it's x minus 4. Are we moving up or down? Up. Y plus what?
2.
Now, if you got your signs wrong, what did you do?
I didn't see the apostrophes.
Right, and you went backwards, okay? I can't tell you how many times that gets messed up. Always start with the one without the apostrophe and go to the one with the apostrophe, okay? All right, so we're going to stop here. If you notice the next section has multiple, so we're going to pick back up there. So for next time, what I need you to be comfortable with is graphing and then reflecting and translating. And Thomas, where are you going to find extra practice in the event that what I've given you is not enough? On Google Classroom with the key.